Namaste. Today in this video we are going to discuss about rules of inference, okay, or it is also known as inference rules, and the second part is logical equivalence. So let us move to the rules of inference. So rules, okay, and name. So first rule is, if P is true then Q, that means P implies Q is true and P is true. If these two conditions are true, then the result is Q. Okay, it is also known as modus ponens. Okay, and next rule is, if P implies Q is true and not Q is true, then it results not alpha. Sorry, not P. Not alpha, not P. Okay, if this condition and this condition is true, then the result is not P. It is known as modus ponens. Similarly, if P and Q both are true, then we can write P and Q is true. Okay, if both are true, then P and Q is true. So it is and introduction. Okay. The next rule is, if P and Q is true, then we can separate it. P is also true and Q is also true. It is known as AND elimination. Okay. Next one is, if P or Q is true and not P is true, then if these both conditions are true, then the result is Q. This is known as resolution. Okay, so sometimes resolution can be P or Q and there may be not Q or R, so it gives P or R. Okay, so this is also resolution. So these are the rules which we use in proofing technique. Okay, there are some other rules. Okay, so for all x, px, qx, then for proving we have to remove this universal quantifier. Okay, so if this is true for certain domain, px is implies qx is true, and this is known as universal instantiation. Okay, and next one is, there exists x, px, qx, then it can be written as px, qx. This is known as existential instantiation. Okay, so these are the rules of inference and which we use in proofing technique. Okay, so that if P is given and P implies Q is true for certain statement, then we can directly write P is true. The conclusion is P. Okay, and we will be using these rules to prove or to derive conclusion. So let us move to the logical equivalence. Okay, so logical equivalence is the two or more predicate can be called as logical equivalence if their truth value are same for the combination of each variable of the predicate. Okay, such as example not A is same as A. The truth table for truth value for this and this are same. So it is logical equivalence. Similarly, A or B is logical equivalence with B or A. Yes. Similarly, A and B is logical equivalence with B and A. Okay. Similarly, okay, P implies Q is logical equivalence with not P or Q. Okay. Similarly, P implies Q is logical equivalence with not Q implies not P. Okay, this is known as contrapositive. Okay, there are many more logical equivalence in which the truth value are same for the combination of each variable of the given predicate. Okay, if you construct the truth table of this and this, the truth value, that means output, is same for the same combination of variables. Okay, so let us consider a small example to use these rules. Okay, let us consider that there is P given and P or Q is given, not Q is given. Okay, then if these three conditions are given, then we can use resolution. Yes, not Q, then it results P. So our final conclusion is P. I am using a simple example, and in next video we will be discussing about proving technique by using the inference rule. Okay, by converting the given predicate into the clauses for proof by resolution. Okay, and for proof by reduction we convert it into this form. Okay, and next one is proof by refundation, and we use simple graph structure to prove the statement or to generate the conclusion of the given question. Okay, thank you and bye bye.